Hello and welcome to By Excellence Tutorials. So in this video, we are going to solve a momentum or collision question. Now, this question gives a lot of challenges and problems to students, to a lot of students, because it has got a lot of unknowns for you to begin solving. Yeah, so I hope by the end of this video, you will be able to know how to solve this one. So we have a billiard ball at rest is struck by another ball. So let's say okay, a billiard ball at rest is struck by another billiard ball of the same mass. So the masses are the same here, whose speed is 6 meters per second. So the one that was moving, it was moving with an initial speed of 6 meters per second. After an elastic collision, the striking ball goes off an angle 25 degrees with respect to its original direction, okay, of motion. So find the struck ball, find the angle the struck ball makes with this direction and the final speed of both balls. Okay, so if we have a ball that is moving like that, and we have that with respect to the x, let's say the first ball goes 25 degrees and the other ball goes at the angle theta there. What we're going to have is this one, this ball was moving with an initial speed of 6 meters per second, and this one 0 meters per second. Okay, so this one moves with that velocity at that angle, and this one moves at that velocity. So we can resolve this where in the vertical we have v1 sine 25. Also this one in the vertical we have v2 sine theta. In the x, this one we have v1 cos 25, and this one in the x we have v1 cos theta, v2 cos theta. So this is what we're going to have. So now, if you can look at this system clearly, you can see that it starts in one dimension and it goes to 2 dimensions. So we are going to write the conservation of linear momentum both in x and in y. So we are going to have 2 equations. So in x, what are we going to have? We are going to have the mass is the same. So I'm just going to say M1, MU1, MU2. These are the initials. And we're going to have M V1 cos 25. This is the speed in the x direction. Also for the second mass, we have, not V2, because the mass is the same, is uniform, they're identical. So all we can see is the M getting stripped off, and U1 is 6. This one was at rest, so this is 0. So we have that being equal to V1 cos 25 plus V2 sine theta. So I can make the one that I don't know anything about, no velocity, no angle, the subject. So I'll have V2 sine theta being equal to 6 minus V1 cos 25. Let that be my equation 1. And from there, I also go in the y. And in the y, what I can see here is that before collision, I don't have anything. In the y here, I don't have anything. So before collision, I have 0 momentum. And for particle 1, it goes up with this velocity momentum, and plus the mass and going down with that velocity. So what I end up having is negative of m v2 sine theta being equal to m v1 sine 25. So I can cancel. Oh, sorry, this one will be positive. I take it aside. So I'm going to have v2 sine theta being equal to v1 sine 25. Okay, so now it is mentioned in the question that the kind of collision that has taken place here is elastic collision. So we know that under elastic collision, both momentum and kinetic energy are conserved. So conservation of kinetic energy here is going to be half mu1 squared plus half mu2 squared being equal to half mv1 squared plus half mv2 squared, like that. So we can see that the half m throughout they go, and this one was at rest, so it will give us 0. This is going to be 6 squared equal to v1 squared plus v2 squared. So this one is going to be 36 equal to v1 squared plus v2 squared. Let that be my equation 3. Now, if you look at equation 3, you can see some squares. And when you look at 1 and 2, they don't have squares. So now I want to combine 1 and 2. So now how do I combine 1 and 2? So for easy calculations or solving, I'm going to square those two equations. Both equations on their side, I square them and add them. When I sum them, I'm going to have something to do with squares because I have equation 3 which has got squares there. Then I'll be able to solve the two equations. So now, if we square equation 1, we're going to have v2 sine theta squared equal to 6 minus v1 cos 25 squared, which is, this is equal to 6 minus v1 cos 25. A lot, they confuse that. So you can distribute that as like that. So here I'm going to have v2 squared sine squared theta being equal to 6 by 6. I get 36 minus 6 v1 cos 25. And then I have also minus 6 v1 cos 25. And I have plus v1 squared cos squared 25. All right, so what I'm going to have is v2 squared sine squared equal to 36 minus 12 v1 cos 25 plus v1 squared cos 25. All right, so I'll take that to be my equation 4. All right. So now I also square equation 2. After squaring equation 2, what am I going to have? I'm going to have v2 squared. Sorry, this one is supposed to be, sorry. From equation 1, this is cos. Sorry. Oh, here it's cos because we're dealing with in the x there. All right, yeah, so this is cos. This is supposed to be cos. Okay, sorry about that. So what we're going to have now, for the one in y, we're going to have v2 after squaring both sides. We're going to have v2 squared sine theta. So we're going to have v2 squared sine squared theta equal to v1 squared sine squared 25. So this is my fifth equation. So I add this equation, both sides. And what am I going to have? Right, so what I'm going to have now is v2 squared cos squared theta plus v2 squared sine squared theta equal to 36 minus 12 v1 cos 25 plus v1 squared cos squared 25 plus I have v1 squared of sine squared 25. So I can see that I have something in common here. So here v2 squared is common. I factor it out. I'm going to have like that in brackets, and here 36 minus 12 v1 cos 25. I also do the same here. I factor out that I'm going to have cos squared 25 and plus sine squared 25, like that. So if you see in the brackets, what you have, those are trigonometry identities, and they are actually equal to 1. So what I'm going to have is v2 squared being equal to 36 minus 12 v1 cos 25 plus v1 squared. So that is my equation 6. So now, using equation, so making v2 v2 squared the subject of the formula of equation 3, this is what I'm going to have. Okay, v2 squared is going to be equal to 36 minus v1 squared. So equating this one can be my equation 7 now. Equating this, I'm going to have 36 minus v1 squared equal to 36 minus 12 v1 squared cos 25 plus v1 squared, like that. And what I'm going to have now is that this 36 here is going to cancel with that, all right? And I take this, the other side, I'm going to have negative v1 squared minus v1 squared equal to negative 12 v1 cos 25. So I have negative v1, negative 2 v1 squared equal to negative 12 v1 cos 25. So now, what do? I'm going to divide by negative 2v throughout, negative 2v1. So that here I'm going to have v1 equal to 6 times cos 25. Yeah, 6 cos 25. So what I'm going to have I have 5.431. 5.44. Okay, let's leave it there. All right, so my V1 is 5.44 meter per second. So now I can use equation 7. I can use equation 7. Equation 7 says V2 squared is equal to 36 minus V1 squared. So now this is going to be V2 squared equal to 36 minus 5.44 squared. So V2 squared is going to be 5.44 squared. It's going to give us 29 point that, and 36 minus that, we get 6.4064. All right. So now we square root both sides of this to get just the V2, since it's V2 squared. So what do we get when we square root both sides? Right. So that is our V2. So we can now use even equation 2 to find the direction. So equation 2, we had V2, no, not squared. We had V2 sine theta being equal to V1 sine 25. We had this. So now V2 we have found we can divide by V2 both sides, V2, so that sine theta is equal to V1 we found to be 5.44 over V2, which we found 2.53, and times sine 25. So sine theta is going to be 0.97. So finding the angle, we have theta, the sine inverse, 0.9087. So that theta is equal to 65.3 degrees. Okay, so that is how you calculate to find this question. So if you have liked the video, kindly let me know in the comment section, and give this video some reactions, share with your friends, even tell them to subscribe to the YouTube channel so that they can also be able to benefit from these tutorial videos. Thank you so very much.